morning, everyone. John Wagner, retired from Customs and Water Protection, joined here by some, some former colleagues and experts, and we're going to talk about the non-intrusive inspection program, also known as NII in CBP speak. And this is a program. These are the big, I'll just say in non-technical terms, these are the big X-ray systems that can X-ray cars and trucks. All different types of technology, all different form and functions and use cases for these. But, throughout my career in customs, we saw these. When I first joined, we thought we were cool because we had an X-ray van and we could put packages through the van and X-ray them on the spot. That grew into building these big, systems where you could X-ray an entire truck at once. It looked like a giant car wash. It's built from there into this program where now you got hundreds of different types of large scale, small scale, all different types of energy and technology to be able to do this. And it's really become a cornerstone and a foundation for the inspection process. And we want to talk about that today and where it's going and, some of the real challenges you have and some of the exciting possibilities you have about what this will do for the land border and the enforcement operation. So Diane, we'll start with you. Can you kind of give us a sense of where the program's at, what it means, and some sense of what's the current things you're most working on?
No, thank you, and it's great to see you. It doesn't feel like you're retired. We see you all the time. This is a good thing. And happy to be here on the panel with everyone today. My favorite USG partner, Mr. Sunil Madhugiri, for sure, who really is kind of the driver of all things that we're trying to do with the data integration and the AI with non-intrusive inspection technology. But well underway, about half of the deployments across the southwest border with the MEPs and the LEPs. That deployment is going to go through fiscal year 26. A lot of big construction projects wrapped around all of these kind of smaller construction projects at the ports of entry. And at the same time, really partnering with the Office of Information Technology to take all of the data, all of the sensors, and tie that information together. And that has really been a lot of the workload for us in addition to these construction projects. But incorporating the artificial intelligence, machine learning into it, we have a couple of business use cases for the algorithm deployed already. We're seeing some great results with those algorithms being deployed. But the reality is, in terms of the scale and scope, when we think about, we were scanning about 2% of passenger vehicles previously. We're going to increase that to 40%. That's going to equal about 29 million scans that we're looking at in terms of the volume that we have. So we could not staff our way out of it. That's where the artificial intelligence, machine learning really is going to be critical. And building it with that human-in-the-loop architecture. The Deputy Commissioner mentioned kind of the weaving in that technology, that hardware and that software into our most important resource, which is our frontline personnel, in the fight against fentanyl, whether it's the agriculture threats that we're trying to tackle. I brought that one up first, right?
Got to always give a plug to agriculture.
Absolutely. The biological threat issues that we deal with, but, the priorities that we have, very matrix and leveraging the technology even across the enterprise and making sure that our partners in CBP, and we're leveraging the tools and the emerging tech that they're identifying, incorporating it into ours as well. So a big landscape that we're looking at. But it's over 1 million passengers a day. Just yesterday, we had 270,000 vehicles cross our borders. Yesterday, 48,000 trucks crossed our borders. Just yesterday.
One day.
One day.
Wow.
One day. 4 million de minimis packages. I know the deputy mentioned that as well. The volume is substantial, and it's not shrinking anywhere. So leveraging those tools. And NII is one of the tools, the artificial intelligence, but the intelligence infrastructure that we have to support it. A lot of resource commitments kind of across a number of different disciplines to tie together.
So the NII systems today, they're used in the secondary environment. You mentioned some of the throughput numbers, but there's a CBP officer and there's sitting in the machine, looking at the screen and interpreting what the results are, and trying to use their training and their historical knowledge and their expertise to say, wait, that's an anomaly, that shouldn't be there. to build these drive-through systems and to bring this up to, you mentioned 40% or, up to 100% of the trucks and the cargo coming through, like that's a couple of 100,000 scans a day now. I don't think you have a couple 100,000 officers since I left. I don't think the hiring's been that great. But even with 30-something thousand officers, 25,000 something officers, like Sunil, how do you best position now the workforce to take advantage of and interpret the enforcement productivity that's going to come out of a couple of 100,000 scans a day? And how do you possibly interpret all that? Certainly can't have an officer there looking at the screen and trying to read all that.
Sure. Thank you, John. It's whenever I come and talk with the panel with EAC Sabatino, it's a tough act to follow. As you can see, she's absolutely unbelievable. Well, I've been working with her for a while. She's a great partner for us and always supporting us with what we do on the tech side. Without them, we don't exist, right? That's the bottom line. She's absolutely, thank you for everything you do, ma'am.
Thanks for the plug. I'll get you later.
Okay. No, she really is. It's unbelievable. So I think that what the difference is with the EAC is that she's forward-looking, and giving us opportunity to think for us at what I'm a techie myself, and I grew up in the industry myself, so been in the government for about 5 years. So to John's your question, right? The word AI, technically has been there for a little while, right? What has changed is some of the tooling around it. If you look at data in general and some of the things what CBP has been doing for a while, especially our current commissioner who started the National Targeting Center and some of the things they were building, working with the targeting systems for CBP, they were using anomaly detections, various things we used to call predictive analytics at that time. That used to be the former name, right, for AI. Now they're kind of converted because now each and every product people are developing has some intelligence built in there. So you're looking at things to do, faster, better manner. Especially when you mentioned about the images, that is exactly because you don't want humans, 100,000, we don't have 100,000 officers to look at this stuff. So the AI component is playing a role to summarize things, look at things, like the EAC said, officers always in charge, AI is assist. That's what we say, right? AI is there just for assistance. Officers always have the final say. But from our perspective, from the tech perspective, the cool thing what is happening now is the tech has dramatically changed, especially last 7 to 8 years. And especially now, I wish I was like 30 years younger. The Gen AI component is probably one of the biggest changes in the tech industry after .com. I don't know how many people remember .com days, but those days was exciting, right? Some were failures, some were good, right? Those companies have grown and become large companies, and some of the startups have done an amazing job. So this is where we are right now, especially from a tech perspective. So how do we take the technology, John, and start applying that to NII component and things like that is what I'm trying to figure that piece out, right? Working with AAC and XC Jody Harden and team on the NII side. A lot of exciting stuff we are doing. I'll talk a little bit more as the panel goes through. But we are, it's computer vision from looking out what the images look like for anomalies. As EAC said, we're deploying some models already. And then what we're going to start doing is how do we make life easier for the officer to interact with some of these things, right? Because they all have a UX component to this. They also have some interactive of data getting information out very quickly for them. That's the part which is exciting now with Gen AI component. That marriage between traditional AI, custom-built stuff, what we are doing currently, with the Gen AI model is where the future is. And I have some examples I can give you as we go forward. But that, I believe, is going to help dramatically what we do with NII. Another area, John, I'm going to talk a little bit more also is on the edge computing. That is changing how we do business. And that, I think, will help industry also.
Okay. Yeah, we'll come back to that in a minute. I got a few more questions for you, too. But Peter, the industry perspective, hearing some of the use cases and some of what CBP is doing and your experience across even different sectors and commonalities and some differences, some thoughts on where this work is headed.
Yeah, no, appreciate it. And I'm going to apologize in advance. I'm on the tail end of a cold, so you get the Barry White voice today. So yeah, and you put me at the end. Should I sit over there? Yeah, sorry about that. But yeah, so I've been at Oracle now, I think over 1.5 years, so a short time. But in that time, what I've seen, not only are we, supporting DHS, super important customer of ours, where a lot of the data that is being processed for, the border crossings and others they're housed and secured and processed within Oracle. What we're seeing just broadly though is the application of using both AI infrastructure within the cloud and at the edge to be able to pull different disparate data sets together in order to have a more complete picture. So from an NAI perspective, if you think of an analogy like in health, you have an X-ray for a patient that shows, through computer vision, there's a potential things within their lungs. But that's one piece of data. It has to be married up with many other pieces of data and fused so you get a more complete picture of what the potential issue is and then how you potentially would fix that. And that is the same thing at the border. It's the same thing in defense where we do a lot of work, and intelligence. It's really the fusion of that data with the NII data together to create a more complete picture, which allows agents to be more thorough, to process things more quickly, and also to discover patterns. And we were at the border, it was several months ago now, cold medicine's kicking in, I can't remember when it was, but, and it was really interesting because when agents were looking at just the patterns of where they were finding contraband in just sedans, it was one particular make, model, color that was more indicative and likely to have contraband in it than any other. And it's a consistent theme because it's a cat and mouse game, right? But it's a consistent theme that as you're able to fuse that data together and see those patterns, you're better able to react in the moment from whatever scan or whatever it is that you're getting at that time.
Yeah, that's interesting. CBP gets tons of information.
Yeah.
And, I think, one of the end visions here is just like what you were talking about, and like Pete was talking about earlier, how do you package all that together to help that officer or agent make the best decision that they can make? So how do you take the cargo description, the manifest information, right, and fuse that with the imaging information and say, look, if this is 20 washing machines, is this what a scan of 20 washing machines should look like? Officers can see this now based on past practice and experience. Yeah, that's what washing machines pretty much look like. I mean, what are these square bricks over here? Those don't belong there, right? So if that's the vision on how, this could end up, and the possibilities for are endless at this point then, right? What CBP can build operations around this, but how close are we to seeing this? What are you seeing with some of the testing? Diane, we'll start with you, and then maybe Sunil, what is some of the impact been? What are some of the, some of the things that are really working well?
What I think, and I'm sure you saw over the many years in your career as well, that once the technology gets out into the field, we always, a lot of training, a lot of messaging that has to go, what is the role and responsibility, of the frontline personnel, but you see them really take it and make it much greater than we could even imagine or envision. I think when we talk about the application of the AI, I mean, these kids, and I can call them kids now because I'm older than most of them, they're pretty smart. They're pretty smart. They're very tech-oriented. And, seeing, these kinds of deployments, I think the feedback, and once we get, we've had some of the algorithms deployed for the NAI, the feedback that we're getting from the officers on the tweaks that we have to make. But again, some really good success with these first kind of business use cases that we've rolled out. They're not the complex ones. We have homogeneous loads. We have passenger vehicles. They're going to be challenging, but focusing and getting the feedback from the officers, right on the specific areas of the vehicles, and we know where the intelligence tells us. We know what prior seizures tell us. There's only so many places in a car that you can really conceal things, but also layering in the other data, right? How many times has that vehicle crossed? So it's layering in all that information. Algorithms that are also telling us about the travel, right? The crossings, looking at, does this make sense? So it's anomaly detection, not just in the NII scans. All of this has to be packaged for the officer. And when the deputy mentioned, right, we're responsible for enforcing 500 something laws, for both CBP and other agencies.
Including agriculture.
In 90 seconds or less. right? When you think about that, they really, so educating the officers is really important, but I think, getting their feedback on the application of it is the most critical kind of stage that we're at.
Yeah, and I think that does a lot for the younger workforce too, as you're recruiting and retaining, younger employees, and they're working for an agency that's doing cool stuff, right?
Mm-hmm.
When we started, we had diskettes and we had dot matrix printers, and Sunil, you mentioned edge plans. Talk a little more on that.
Sure. Before I go to edge, can I talk a little bit about what EAC said about the packaging piece and some of the model deployed? Is because I want to paint a story, right, as to what exactly is going on. I tell you, it's what EAC mentioned with respect to some of the deployment models. Right now, some of the smaller, simpler models. Even to do that, there's a lot of work has to go at the back end. Mm-hmm. And the number one thing which we go through, and I hope there's going to be a quiz after this, it's called data engineering. I mean, that is probably the toughest part of any AI work we do within CBP and anywhere else. And the same thing applied to us. And EAC will, she knows some of the challenges we went through. I tell you, I never thought in 1,000 years, the hardest thing which we will deal with is data labeling.
Hey, how you doing?
Data annotation, data labeling was probably the most challenging part for us. Not for anything else, it's because of supervised versus unsupervised models, and these models behave differently. Yes, you can have an officer sit there and keep updating these models, but that's not the point. The point is to automate everything so that they can do their day job and do everything else, right? So that's what we are struggling with. But what other piece of what we have done is, I think it's from the industry perspective. Right from the beginning, I had a vision working with EAC Sabatino and actually Jody Harden is saying that we need to have a common framework so all these models go through a similar pipeline. That means the end result, that means beginning to the end, it's the same consistent feeling across the board. No different for software development, right? If you are software developers, if you guys are aware of that, how it works, have you heard of it's called a SecDevOps pipeline? This is called a data pipeline. Same concept. Model comes in here, go through the process, scanning, testing, everything else before deployment, and then gets rehydrated again with new information, right? That's what we have done. So you'll see more and more. This is just only for NII. We are doing this across the board for all model deployment for within CBP. And the reason is, the EAC mentioned about integrated package, some of the laws which we have to follow to make sure we're not only helping CBP, but across the board for other agencies. To do that, we need to have a consistent architecture across all of CBP. That includes Border Patrol, AMO, and OFO, and of course, Office of Trade, right? That's what we do. That's my job from my side. So because of this now, because of this whole architecture discussion, what has happened is, if you currently 60 to 70% of all data getting generated, John, right now, is at the edge. If you're a global entry customer, thank you for your business. That one, you're at the edge looking at a screen right now, and it's doing something for you, generating some data and putting it out, right? All those are edges now. If you're looking at a sensor, you're looking at NII, scan we talked about, these are all edges for CBP, right? Border wall, sensors, you just name it across the board. Border Patrol has cameras, OFS cameras, all those components are considered edges. That's where the data is getting generated. And this is where we need industry's help. What is happening is the edge computing component, for CBP's perspective, we're coming out with an architecture as to how do we deploy edge architecture, do processing at the edge, whatever needs to be done, including for NII, and then send the data back to a centralized, in the cloud we call it, right? Like a spoke and hub model. That's what we're looking at, right? One more thing I want to tell you that when you talk to us, please talk to us. We're looking at open architecture. I believe in 3 words: open, open, open. All right, it's all open architecture, not commodity stuff, so we can swap out stuff, put everybody's model in there, right? Every cloud provider, every vendor who's providing models to us is what we're looking for. So that's exactly, that's the vision across the board, right? Not only from OFA perspective, and both EAC and actually Harden have been very supportive on this one. And you'll see from our perspective, that architecture is, we just about to publish our edge strategy. That strategy talks about exactly this. How do we take all these remote devices, bring them together, analyze for retention and everything else, plus also processing quickly, as EAC said, 90 seconds to do certain things. How do you do that? You can't bring the data back, process and send it back. Too late. Physics doesn't go away, right? The law of physics still stays. So because of that, you have to process a lot of things on the edge. And that's the strategy we are following, John.
Right. And that was always the thing, right? The latency in the responses. When you get information back so you can decide what to do. Does this person or does this piece of cargo need more scrutiny? But you're sitting there waiting for the the clock to go away and get the results back. So yeah, when you can speed that up, commerce can speed up too. So Peter, anything like the government should be particularly focused on, or any advice you can give the government or even the industry to look at, like these are areas where things should be focused on, or ideas that they should be considering to incorporate as things develop. Like I think Sunil just mentioned, just some of the rapid changes in technology and the new things that are out there on the edge, the other edge, right? Like what's on the horizon that they may want to be thinking about now?
Yeah, I appreciate that. I mean, specifically within the AI field, there's maybe two things top of mind, and Sunil mentioned it. Actually, maybe three things, maybe four. All right, we'll see. So, of course, data is the foundation of all AI. And it's really important to understand that the AI's output is only going to be as good as the data and so forth. We all know that. Intuitively, however, doing it is really, really hard. And so for government to invest in the way that Sunil was talking about, absolutely the right path. That's what we see across industries, across other government entities and so forth, moving in the way that he was describing. Absolutely, we see a lot of movement around data mesh in particular, where you leave data where it is, but you allow to have the ability to do analytical products that then can be shared broadly across an organization. We see that in the industry. We have the largest data mesh in the world, processing all the financial transactions that run through our data mesh. It's like $3 trillion a day. That's high speed, like low latency, that type of thing. Government focus and moving towards that, I think, is important to enable AI applications. AI infrastructure is really important, especially as you're thinking about these models. They're getting large and they're complex and expensive, not only to build, but also to run. We're deploying data centers and AI infrastructure GPUs, like thousands per week, right now for industry. And government, I have seen, especially maybe more on the defense side, hasn't been as forward-leaning in being in a cohesive strategy in buying and procuring and securing that type of infrastructure. And so I think that's something government needs to be thinking about. And then lastly, what I would just say is, generative AI is super exciting. I actually was at Microsoft before. I was at Oracle working with OpenAI as all this was unfolding, and have been a researcher for a long time. Super exciting. What I think government should be thinking about specifically, though, is really around transparency. The challenge that we've seen in deploying generative AI within a government context is, all of these models are built by commercial companies, and they put filters, they have specific data sets that they use, not always known or published what those are. And so we had several POCs that we've been doing in the defense area where the generative AI had filters on it, which prevented us from getting what we expected was kind of the right answer. And it wasn't published, it wasn't known. So really, we're doing a lot of work. We're investing a lot of work in our labs, and we're partnered with Meta and Cohere and some of these large language models that, they are focused on providing that transparency to government. But I think that's a really important, key thing that often isn't thought about when they're thinking about Gen AI deployments in particular.
Right. Interesting. So Diane, thinking about all the investments CBP's making in the border, drive-through NII systems, up to 100% of the scans coming in, getting good quality data from the industry that you can target and analyze and, pick out what needs more scrutiny, what doesn't. All the biometric work you're doing with pedestrians, with the vehicle systems. Fast forwarding 5, 10, 15, 20 years, what does that border of the future look like? How will people and companies experience this? But also, what do you expect? How do you expect the risks to change? So the risks you're addressing now with the NII program and the scanning, some of those risks are going to change, right? Once that capability is there to address them, how do you monitor and react and shift to where those threats are going to go, right? The drugs are going to continue to come in. Maybe they go other places now.
No, absolutely. And that's mentioning earlier about the investments have to be across a number of different disciplines, and the intelligence infrastructure that we have to build out to support the frontline personnel. It's the data that we have, but it's also the intelligence that feeds that decision making, and making sure that we have the right tools to get that data and that intel really integrated. And building the systems, working with OIT, but also things like threat briefings, right? But we need the people, the intelligence research specialists, those type of investments, that we need to continue to be focused on. I think, in terms of the newer technology that we're looking at, when those threats move, or our adversaries, look, they're moving faster than us, when it comes to seeing what we're putting up in terms of the enforcement posture, right? And we always have to have that redundancy there to make sure that we're kind of looking across the entire landscape at all times. But what else is out there, right? That those concealment methods, and NII is, again, one of many tools that we have, the AI, one of many tools in the toolbox. But some of the newer things that we're looking at, excited about the diffraction technology, and I do not have the technical expertise to really explain what it is, but I know that it's really looking at like material structure and the composition of things with the technology. And it's exciting because we have resources like seized property warehouses, where we have lots of materials to work with industry to help build libraries, right? To identify things like synthetics, precursors, methamphetamine or cocaine, heroin. How do you find this, right? And partnering with industry when that type of technology is starting to be developed. We're very much interested in doing that, already working some of the details. But as these new technologies really start to develop, I think, biometrics, you were, right at the front line with trying to gain the advocacy for facial biometrics and why it was important. And I say, and this is not, tied to any particular administration, looking back across the last 27 years of my career, it's always great when you figure out a way to do something and there isn't a policy or oversight that exists yet, to be able to roll it out.
You can get away with it for so long before they catch up.
When you can be in the position to write the policy and have the success and the advocacy before the policy and the oversight kicks in, but you have to do it right. You have to be judicious about it, because if you do it wrong and the oversight kicks in, it's a disaster, right? But being at the forefront of that, and really that's where like government and industry have to be really focused on those key areas. I'm not advocating for running out and just, moving away, but AI very much the same. There's a lot of concern, facial biometrics with the privacy, making sure that they're the cornerstones of the programs, that we have those protections and security, that the data security built in from the beginning. But there's a lot of great stuff that we can really dive into and write the policy about it.
Yeah, and that's a great point. I mean, the government's in a unique position where, like, they can develop a lot of these things, and they can push the envelope on a lot of new ideas and implementation of it in a deliberative, structured fashion, right? And like you mentioned, you have the things to build libraries, right? You have stockpiles of, seized property, narcotics, different things that you can build. You can build these types of libraries against to be able to test it.
Yeah, 127,000 pounds last year.
Right.
Wow.
Do you see at some point with the land border, have you put out any types of timelines as far as, what percentage of cars and trucks will be scanned, or how many pieces of equipment will be out there, and then like after the southern border, what's next?
Yeah, we have about 158 systems to deploy. We're about halfway through. It's just under 80 deployed between MEPs and LEPs. But I mentioned earlier with the
Hey, pretty good.
passenger
Pretty good,
vehicles,
Megan?
right? It's going from 2% to 40%, which is like 29 million scans. And I'm bad at math on the fly here, but with the commercial vehicles, it's roughly like 15% to
And
at least
Mr. Miller's
70%.
here,
The
right?
goal is 100%, but we have to figure out some things with Mexico, maybe with non-intrusive technology in Mexico to get to the 100% just because of the physical footprints.
Right, some of your ports are right on
You're in the
border.
second car, you're in Mexico.
Right, like the line's
At
like right
primary,
here.
Yeah. So figuring out those, but the vision, you mentioned before that I kind of failed to answer, right? It's that at speed, right? That's the goal. It's to get the facial biometric. It's to get the data well in advance, and we have some other things that we have to figure out for advanced passenger information across our land borders, right? We have mobile applications. Can you submit mobile applications? We've learned a lot from our air industry partners on communicating, with the traveling public. Why can't we do that in those spaces? Get biometrics in advance. We already have a lot of data for the crossing. So at speed and really taking our officers away from, do we have to talk to every single individual that crosses? Do we have to physically look at every single conveyance that crosses? No, we can automate a lot of that work and really focus on the threats and our frontline personnel, our officers, our ag specialists, resourcing them to do what they do best, which is to talk to people, the ones who we need to, the threats and the unknowns.
Right. And like you mentioned earlier, like they take this new technology, they tear it apart, they find different ways to use it like we would never even think of. And it's just the enthusiasm that they bring to that. And you go out to the ports and you see how they've locally modified it to fit whatever, needs that they need based on logistics and other concerns. But with our closing few minutes, let's open it up for any questions or comments that we've got one right here. So here comes the microphone.
Thank you. Phil Hassel with LMI. You've talked a lot about, the massive undertaking it is to deploy NII around just the pure construction and physical infrastructure, but also the technology supporting it as well. Can you talk a little bit about the challenges you're looking at and foreseeing as NII is being implemented around the logistics tail and the sustainment?
Around, I'm sorry?
The logistics of the sustainment and the O&M side of it.
I think, in terms of the technology, and this is where kind of, we talk about like the open architecture, right? And not putting all our eggs in one basket, but the long-term vision for us. I mean, we're looking at it with radiation portal monitors now. Our plan can't just be to, keep replacing panels in the radiation portal monitors, right? There's better technology that's out there today. And I think, I'm not going to say that we're not talking about the long-term for the NII today. We're just trying to get it in the ground and get all of the data integration done. But today we need to be looking at what that new technology is. And I mentioned the diffraction technology. There's muon technology that's out there. There's going to be continuing development. And is it always going to be an MEP or an LEP? What is that future vision? But again, that's where we're going to be overly reliant, frankly, on the industry to help us get to the next piece. I think in terms of the budget cycles, look, it is, frankly, and I'll say it, too long for the technology to be deployed that we received the funding for back in 2019. But frankly, with all of the different entities, everyone with skin in the game, there's probably hundreds of different touch points when it comes to getting this technology in the ground. But what I will say is that a lot of lessons learned that moving forward and looking at what that long-term vision is, we have some clear paths on how we're going to get there. Right, and mitigating, I think also, in terms of funding, good stories and understanding who the advocacy groups are within USG and outside of USG that we really need to touch early to get those deployments and find out what's next.
Mr. Ragland.
Just a follow-on question. Thread back to Sunil. Open, open, open. Here's where we tie it together. Things are moving in the AR world rapidly. Bringing it home today. We're listening to the plethora of comments coming out of New Jersey because of the drone observations and tracking. Yesterday in a CBP conversation, it came up in the same way, but there's a parallel. Open, open, open is where we need to go. But inside right now, we have some proprietary system where the filters are being applied to the data, and it's not getting back out to the operators, analyzed, inferenced as quickly as we can. We need to focus on that. One of the observations from yesterday's CBP conversation was, look at where the leading bleeding edge information is coming from right now. And around the room, it was the Ukraine, because they're dealing with the counter drone and the drone threat in real time. We didn't have anybody in the conversation yesterday who was linked to them because of the existing filters. So, Sunil, back to you. Any insights on how we can accelerate the openness for the data? Because the operators are starved.
Right. It's an age-old question, right? It's technologies keeps changing, right? I've been doing this for a long time. Tech has changed over the years, right? And open standard it's a tough area because there's certain open standards which we know, right? TCP/IP, like you could think about your networking protocol, right? Think if you don't have TCP/IP. That's an open standard because there are certain things you build on top of that, right? And there are other technology areas where if you're moving data, for example, LinkedIn came out with a concept called Kafka. Kafka is an open, real-time architecture sending data from point A to point B, for example, right? So, but legacy systems, as you mentioned, probably are not tuned for those kind of things. So what happens is that in a lot of cases, the existing systems, you have to start working with that and start building some architecture on top of that, which kind of takes advantage of these open systems. So ultimately, those systems are going to get replaced, right? So we are hoping that when you get replaced, the next system you're building and the industry you are coming to us, talking to us, are also working on these open standards, right? And that's the age-old chance that doesn't go away, right? 50 years from now, there'll be something else we have to worry about open standards. But as of right now, we are very confident from operating system onwards, upwards. I know that I've worked the whole stack for a long time. Things are getting more and more open in general. I'll give you a good example. The good example I would say is the large language model, foundation model we are working on. These companies are working in such a way, what CBP has done is we approved 3 models right now. We approved Llama, which is from Meta, came from Meta, right? Second one is Mistral, and the third one is Gemma. These are all open source models. What does that mean? We are hoping, I know for a fact our developers will not be touching anything else. Otherwise, they are in violation of software development within CVP. That's one. Second thing is when we work with you guys and knowing our open standards are, when you come and talk to us, you need to understand that this is what the open standards we are using as of right now. Because see, this is a green left field, new stuff we are working on right now. Existing systems, we are hoping that, this is what other thing we have done. So we are putting what is called in between, like some kind of in-between architecture, which kind of merges those two things. Let's say we talked about Oracle databases and things like that. How do we take those databases, which is like a RAG model database, how do you take that, marry with LLM, for example, right? Yeah. So we have a concept called agentic functions. We are creating functions. Those functions are the thing we just talked about. It can bridge that gap between the two. It makes sense?
Can I add on to that real quick? Data sharing always an issue, right? Even if it's a corporation or government, et cetera. Where we're seeing government move to is more of a data mesh type architecture, like I talked about earlier, that Sunil is referring to as well. That helps enable, at least when you know there's a filter, it allows you to share data in a different way without necessarily having to move it, and also to share analytical products. So we see that, like if you look at the Army, they publish UDRA, which is their the way that they're thinking about all of the data they collect from mission to back office to everything. How do they mesh that together and leave it in place, but also from a technology perspective, allow the sharing more rapidly, and it's an event-driven architecture, meaning if there is a piece of data that somebody else needs to see, it's driven by the event so that it gets published to the person who needs to see it. So it's things like that, that's a technology problem. It's always a cultural problem, not a technology problem. But from a technology standpoint, that's what we're seeing more and more adoption of.
Okay. We've got time for one quick question. Your hand went up first.
Right. Hey, I'm Thomas Anthony. I'm the founder of Analytical AI. We are in the NII program. And so the question was for ESC and for Sunil. So for us to build algorithms, we need that data. On the TSA side, we build a lot of algorithms for TSA. We go to their labs, have guns, knife shops, and bags, collect that data. Is there a plan on the CBP side? So because we can't create that data, we need to get seizure data from CBP. Is there a plan to create that data? And Sunil, you said annotation is expensive, it's difficult. So if it can be collected in a controlled environment, it becomes really great for industry to build those algorithms for you guys. So is there a plan to go that route?
I'm glad you asked, because I forgot to mention that. So yes, there is a plan, and you're 100% correct, right? So what we are doing as of right now is that we are in the process of starting to create what is called creating synthetic data. And we are working, I can't name any companies, I'm not supposed to, I will not, but we have what's called an iLab within CTO office, and we are in the process of working with the O4 team to create a synthetic data. 100,000 images are being created as we speak, and you'll see some of the things what you just talked about, right? And it, again, as I mentioned, right, that is the hardest part. As you know, since you're in the NII space with us, you know how tough that is, right? So I'm hoping the synthetic data, right, what we're creating. Another thing I'm going to do here is, or we want to do here as CBP is marry that with a computer vision concept with LLM component, because what is happening is these LLMs can create synthetic data also now. You see what I'm saying? I don't need a specialized company to do this anymore. We can actually do Llamas of the world, Mistrals, what 3 companies we have chosen for their models, for open source models. They can start doing these things now. So that's why what will happen is the integration piece should be faster, because I can marry that piece with the NII, your custom-based model which you guys are building. Make sense? So that's why we are. Just hang on. If you talk to me offline, I can give you more information what we're doing with that.
I'm good.
Good. Well, thanks everyone for the time. Thank Diane, Sunil, and Peter for your time as well too. I know you have very busy days, and thank you.